Today we are going to complete the notes for continuity. We're going to be reviewing a couple of skills from pre-cal, specifically how to graph piecewise functions. The worksheet that you have, Functions Worth Considering. You have two worksheets in your possession right now. Functions Worth Considering and Continuity 1. Functions Worth Considering may be done with a calculator. Continuity 1 is supposed to be totally done without a calculator. And the quiz tomorrow will be no calculator. Okay? So, one of the things that is on the functions worksheet is piecewise functions, and I'm not sure that all of you have been shown how to graph piecewise functions on the calculator. So I am going to teach you how to do that today. If you like it, on any question that I say you can use a calculator, you can graph it with a calculator. Some of you may say, I don't like the calculator and I'm going to do it by hand. You can do it by hand. I don't care. I will not force you to use the calculator to graph these. I will force you to do it by hand, at least once. Okay? So, here is the first piecewise function we're going to look at. Let f of x equal the following three piecewise functions. So go ahead and draw your braces thing 3 lines wide. The first equation is x squared, for x is less than 0. Then the square root of 4 minus x squared. 0 is less than or equal to x is less than 2. And then x minus 3 for x is greater than or equal to 2. So there are your 3 pieces of graph. We're going to be examining this graph. We're going to graph it. We're going to talk about whether or not it's continuous and why. Okay, so the first thing I want to do is to draw a complete graph by hand. So you're going to need to draw a pretty good sized grid. I need you to go out 5 marks in each direction. Try to space them out pretty evenly. Like so. We have used piecewise functions already this year, and the way we've used them is to find limits. We haven't really done much graphing. Now we're going to focus on the graphing, and we're going to use them to find whether or not a function is continuous. So, we're going to draw the little number line like we did before. What point should I put on my number line for this one? Where does it change from piece to piece? 0 and 2. So over here, I'm going to draw my number line, put 0 and 2, and then I'm going to get my other color. I'm going to number my equations 1, 2, and 3. And I'm going to define each point or interval here based on those equations. So, which equation is defined to the left of 0? 1 is. Which one is defined right at 0? Why? Because it's less than or equal to. Which one's defined between 0 and 2? 2 is also. What about right at 2? That is 3, because it's equal to on the third equation, and then 3 is the equation to the far right. Okay? Now, as far as graphing goes, what we're going to focus on are the points where the interval stops or starts. Okay? So, we're going to take this first one. The only x value that it tells you is definitely there is 0. So I'm going to come out to the side. I'm going to write 0 right there. And I'm going to find the coordinates of that stopping point. If I substitute 0 into the first equation, what do I get? 0. Is it open or closed when I graph it? Is it an open circle or a closed circle? Open. So I'm going to draw a little degree, what looks to be a degree symbol, to remind me that when I draw it, I'm supposed to use an open circle.
How do you know that?
Because it's only less than. It's not less than or equal to. Okay? Now, substitute. In the second equation, we're using both 0 and 2. So we're going to put 0, comma, something, and then 2, comma, something. When you substitute 0 into the second equation, what do you get?
2.
You get 2. Will that one be open or closed? That one's closed because it says 0 is less than or equal to x. So I'm going to draw a closed dot like an exponent. Now for 2, when you substitute 2 into the second equation, you get 0. Open or closed?
Open.
That one's open. So we're going to put an open circle up there. The third equation, the only value mentioned is 2, so I'm going to put 2 comma. Substitute 2 into the third equation. What do you get? -1. Open or closed? That one's closed. Okay, now, that is all the information you need to graph this function. This information we're going to come back and use when we're talking about its continuity, but that's really what you need for graphing. Okay? It does help a little bit for the graphing. Let's take the first equation first. 0, 0 is supposed to have an open circle, so I'm going to draw an open circle right there. Now you are seeing why we have been hounding you about parent functions since Algebra 2. Okay? Here is where I need you to know what these look like so that you know what to graph. First equation. What's that graph look like? It's a parabola, right? Okay? Now, based on what it says, am I supposed to draw the whole thing? No. Which side of the parabola am I supposed to draw? The left side, for 2 reasons. Number 1, it says less than 0. Number 2, the 1 is to the left of 0. So all I need you to do is just sketch in the left half of a parabola and draw an arrow on it. That's all I need you to do. That's good enough for me. Okay? Now, the second piece of graph. That equation is not quite as obvious. We have never really done a radical that's got a squared in it before. So we're going to examine that one a little more closely. But I am going to go ahead and plot these 2 points. 0, 2 with a closed circle and 2, 0 with an open circle. Now, is it possible that I'm just going to draw a straight line between the 2 of those?
Yes.
Okay? Why would you think that?
Because it's a squared function that is,
It's the square root of a square.
It's the square root of a square. That's a good
That's
thought.
best team.
Okay, but let's take a look at this. Can you rewrite this equation as 2 minus x? Is that allowed? Is that mathematically legal? What do you think? 4 minus x squared. Does the square root of 4 minus x squared equal 2 minus x?
No, it doesn't. Right?
No, it does not. You can pull things out of radicals if they're multiplied, but not if they're subtracted. Now, if this had said the square root of 4x squared without the minus sign, is the square root of 4x squared equal 2x? Yes. But the minus sign does not allow you to do that. If you substitute numbers in there, you'll find out it doesn't work. Think about it. Put a 1 in there. The square root of 4 minus 1 would be the square root of 3, right? So if you could take them out, you would get 2 minus 1. That's 1. Totally different answer. Do you see what I'm doing? It doesn't work. So this is not 2 minus x. It is not linear. So this is not going to be a straight line between the 2 of those. So what is it going to be? Well, so what I'm going to do, it is going to be a curve, but what's it going to look like? I'm going to take this equation, and I'm going to write it over here. And I'm going to play with it a little bit. Try to move it around or rewrite it or something. And maybe it'll turn into something that I'm familiar with. Okay? So first thing that's really kind of bugging me about this equation is the fact that it's got a radical on it. Is there any way I could maybe take that off?
Where?
How about squaring both sides? Let's try that. Let's try that. Maybe we'll turn it into something we recognize. So the left side will say y squared equals 4 minus x squared. Now they can come off. That square does take the radical off. Okay. Well, that's a little better. But usually when there's an x squared and a y squared, they're usually on the same side. So let's move that x squared over to the other side. That negative x squared, when I move it over the equal sign, will turn to a positive x squared. So I have x squared plus y squared equals 4. Oh, does that look familiar? That's a circle. That is a circle. So this is a circle with a center of what? 0, 0, because there's nothing added or subtracted to the x and y. And the radius is what? 2. Radius is 2. Very good. So these 2 points connect part of a circle centered at 0, 0 with a radius of 2. Now do you know what it's going to look like when you connect them? It's just going to go, it's a quarter circle. So we'll go just like that. That's what it looks like. When the equation of the circle is in this form, When it's in the radical form, that means only the top half of the circle. That's how you write the function if you want it to be the top half of the circle. If I wanted the bottom half of the circle, does anybody know what I would have to do to the equation? Make it negative, put a negative out in front. That's what I have to do. Okay, so that one wasn't quite as obvious. Parabola, obvious. I hope this one's obvious to you.
Yes.
Okay, first of all, let's plot the point in question, 2, -1. Put a dot right there, close circle. We're doing the third equation now. What kind of graph is number 3?
Linear.
It's linear. Is it a line like this or a line like this? First one or the second one? First one. Okay, so it's going to go like that. Which side of the dot am I going to graph the line on, top or bottom? Am I going to graph the line up here or am I going to graph the line down here? Okay, somebody who said top, tell me why.
Because it's x is greater than 8.
This tells me y right here, and also it tells me up here, equation 3 is supposed to be graphed to the right of 2.
Bam.
So very good. Now, when you're doing slope, you can start counting slope anywhere on the line. So I'm already right here, so let's do it. Up 1, over 1. Slope is 1. Up 1, over 1. There you go. There's the line. Okay.
So, since that equation is set, oh no.
Okay? Any questions? So do you see how the points just tell us where to start, then we use what the equation is to figure out what to graph. Okay? Now, next part of the homework. Is f continuous? And explain. ... Okay.
So, you're not going to have that y side of x. It's above x.
Correct. Exactly. All right. Now, we are now in an AP college level course. Explanations have to be mathematical in nature. You cannot describe a graph. You cannot say it's not continuous at a certain point because the graph is broken. That's an Algebra 1 or an Algebra 2 level answer. That's not a calculus answer. Calculus answer wants math to go with it. We're going to prove it. Okay? Not a formal geometry proof like those of you in pre-AP had to do. This is just a regular working with the problem. Now, here's my question. Are all of the points along this piece of parabola continuous?
Yes.
Along this piece. What about the quarter circle? Are they continuous? Yes. Are these continuous? So where is the graph not continuous?
At the point 0 and 2.
0 and 2. From looking at the picture, it's pretty obvious. Agreed? It's broken. It's not there. Okay? So what I'm going to do is I'm going to divide my paper in half, and we're going to go through the proof process for 0 and 2 because it's continuous everywhere else. Okay? The first one we're going to do with just the picture. The second one we're going to do, and we're going to pretend like there is no picture and do it that way. Okay? Now, 3 things have to be equal to each other in order for a graph to be continuous. Does anybody remember one of those 3? Or all 3 of those?
Wait.
What 3 things have to be equal to each other in order to be continuous? L1, L2, and L3. What does L1 and L2 and L3 stand for?
Limit approaching from the left.
Left limit,
And then
the right limit, and the point. Those 3 things have to be equal in order to be continuous. So that's what we're going to do for this problem. So since we're working just with the picture, I'm going to scoot up the work and do it this way. We're going to write the limit as x approaches 0 from the left of the function, the limit as x approaches 0 from the right of the function, and then f of 0. Those 3 things have to be equal in order to be continuous. We already know it's not. Now we're going to prove why. Okay? Okay. Looking at the picture only, as you're approaching 0 from the left, which piece of graph are we looking at, the parabola or the quarter circle? The parabola. What is it? What is the limit as you approach 0? 0. Okay? 0 from the right, we're looking at the quarter circle. What is the limit as you approach from the right? It's 2, isn't it? Now, How do you find f of 0 from the picture? Where's the dot? And the dot is where? At 2. Okay, so in order to be continuous, those have to be the same. They are not the same. So basically, I have mathematically proven that it's not continuous. So I'm going to write no because why? Why is this not continuous? What's not equal?
L1 is not equal to L2.
Okay, now let's not go with L1 and L2 because those can change in definitions of which one is where. There's another way we can write it.
LHL is not equal to RH.
Very good. Left-hand limit does not equal the right-hand limit. That's it right there. Does that make sense?
Why didn't you put therefore?
Therefore is a conclusion after you do things. I am answering a question, is this continuous, yes or no, why? Gotcha. Okay. All right. So, do you understand how to look at the graph and find out if it's continuous and prove it? Because that's what you're going to have to do in the quiz tomorrow. Okay? Now, the other thing you've got to be able to do is to do this given no graph. Okay. Given just that equation, can you tell me that prove to me that it's not continuous at 2? And I'm going to show you, if you're kind of like, no, I'll show you how. We're going to do the exact same process. The limit as x approaches 2 from the left of the function. The limit as x approaches 2 from the right of the function. And f of 2. Those three. Okay, you've done this before. We just are adding one extra step, the f of 2. We've never done that before, given just the equation. Okay, when we did this before, 2 from the left, we go up here to this picture, to the left of 2. Which equation are we looking at? Equation 2. So we go to equation 2, since it's the number 2, plug a 2 into equation 2. What do you get? 0. That's the limit. Didn't look at the picture, got it from the equation. Do I need to say that one more time? Okay. So 2 from the left, so I go up here, here's 2, go to the left of 2, go up, that says equation 2. So I go to equation 2 and plug in 2. Whatever answer I get, that's the answer to the limit. Okay? Now let's do 2 to the right. Go up here, what's to the right of 2? Equation 3. Go to equation 3, plug in 2, what do you get? -1. Okay, now, how do we find f of 2 off of this? The one that's exactly on 2. Which one is exactly above 2? 3 is. That's the equation you plug it into. 2 minus 3 is -1. So we just found all those limits without even looking at the picture. Let me pull my hand away. Does the picture match what we found? From the left of 2, it's going to 0. From the right of 2, it's going to -1. And the dot's at -1. So you see, sometimes it takes too long to draw all this. You need to be able to do it just from the equation. Okay? So, is it continuous at 2? No. So this is a no because why? LHL does not equal RHL. Okay? Now, I want to write it a different way also, and I want you to see if you understand what this mathematically says. This is an alternative way to write it. The limit x approaches 0 from the left of the function does not equal the limit as x approaches 0 from the right of the function. Does that make sense? Yeah, that's just another way to write it in more fancy mathematical terms. Okay?
Would you change it so that x approaches 2 from the other?
I did it again. I did that last period. Thank you. There should be 2 here and 2 there. Good job. You're right. Thank you. Yeah, we're doing 2, not 0. Appreciate that. Good catch. Anything else about this problem? So, on the quiz, you may be asked to do it given a picture. You may be asked to do it given an equation. And drawing the picture takes too long. So you've got to know how to do it both ways. All right? Now, moving on to the next part. I need a new sheet of paper. This is on the back of worksheet 1 as well. A problem that looks like this. What value should be assigned to A to make the function continuous at x equals 4, question mark. That doesn't make any sense because I haven't given you a function yet. It will in a second.
Is this a
Different totally problem. Same concepts, different problem. F of x equals just 2 this time. Three x minus 4, x is less than 4. Ax plus 1, x is greater than or equal to 4. All right. What kind of graphs are both of those going to be? They're both linear, aren't they? So I've got one line here, and I've got another line, say, right there, okay? I don't know what A is, but A can change the graph in a way to where if, let's say I changed its slope and extended it down, it would be continuous. Do you see what I'm saying? So that's what I'm trying to do. What do I need A to be, the value of A to be in order to make the graph, make the two pieces meet? That's what I need to find. All right? So we're going to start like we were going to graph it, but we're not going to graph it. Okay? Draw the number line. 4 is the point in question. Get my other color. 1 goes here, 2 goes here. We're doing this totally without a graph, so we need the number line. Which equation is to the left of 4? 1 is. Which equation is to the right of 4? 2. Which equation is on 4? 2 is. All right. Now, one more time. What are the 3 things that have to be equal to each other for continuous? Okay, let's not do L1 and L2, L3. Let's do left-hand limit, right-hand limit, and f of 4 in this case, right? The dot. You can say the dot if you wanted to. So, what we need to do is we need to find the left-hand limit, the right-hand limit, and f of 4. And in order to make it continuous, they all have to be the same value. So, we're going to do the limit as x approaches 4 from the left of the function, the limit as x approaches 4 from the right of the function, and f of 4. Those 3. Okay, to the left of 4 is equation 1. So I need to substitute 4 into the first equation. So that would give me 12 minus 4. First equation's limit is 8. Does that make sense to everybody? 4 from the right, I'm supposed to plug it into equation 2. And it's x approaching 4, not a. So you're substituting 4 in for x. What's that going to say if I put 4 in for x? 4a plus 1. Does everybody understand that? Okay. Now, f of 4, go to the 4. That's equation 2 also. So it's the same answer I just had, 4a plus 1. So, what do those 3 things have to be? Equal to each other. They all equal 8, don't they? So what am I going to do?
You have to make 4a plus 1.
They have to make 4a plus 1 equals 8. These two already equal each other, so we're good there. We just have to make these two equal to each other. So I'm going to write, since the left-hand limit has to equal the right-hand limit, and you don't have to write this every time, but I'm just showing you. 4a plus 1 has to equal 8. Solve for a. 4a equals 7. A equals 7 over 4. And that's the value of a that will make that graph continuous. Okay? I'm going to check it. In order to be continuous, these three have to be the same. Substitute 7/4 into here. 4 times 7/4 plus 1. 4 times 7/4 is 28/4, which is 7 plus 1. Sure enough, that's 8. Do it in this one. Same thing. 4 7/4 plus 1. They are all 8, therefore it's continuous. I haven't even drawn a picture, but I know it's continuous. Okay? Questions? Yes, sir.
Couldn't you just, from the very beginning, just substitute 4 and make it your code?
That's what I'm doing. But I'm writing it out mathematically to show why. Yes, you need to, because you're showing the proof. Okay? Now, this is going to segue into the next part, which is showing you how to do this graphically. Check it on the calculator. So that's what I want to do next, okay? So I'm going to draw a line, and we're going to check this on the calculator. And so I can move the paper up and have the calculator under the screen. I need to rewrite the functions right here. 3x minus 4, x is less than 4. 7/4 x plus 1, x is greater than or equal to 4. I'm going to move this way up so that I have room to put the calculator below it. And I'll move it. I need to move it up even farther. There we go. Okay. Now, if you have a school calculator, if you would clear it for me, please, because everything's going to already be in there if you don't. So go ahead and push 2nd plus 712 for me and clear out everything that's there. Okay. When you put piecewise functions in the calculator, you must put each piece into a separate line, y1 and y2. Okay? So I'll have it showing up here, and I will have it, I'm actually going to cover that up in just a minute so that you can see. The first thing you're going to type in is 3x minus 4, the equation. Then you're going to type divided by, open a parentheses, and then type in the domain restriction. X is less than 4. The less than symbol is in second math. That's where all the less than and greater thans are. So if you go to y equals, and just type in what I wrote down. 3x minus 4 divided by parentheses, x, second math. I need less than, so that's number 5. 4, and close parentheses. When you are done typing, graph it on Zoom 6, and you will be able to see the end of the line stop graphing before it's totally done. Anybody having calculator issues? This is what you should see when it graphs. Line that just stops right there. Okay? Let me ask you a question. What's the y value where it stops? It's 8. Why is it 8? Look at your work that you did above on your paper. What is f of 4? It's 8, isn't it? It's stopping at 8. Okay. The calculator doesn't really show that because we've only shown the left-hand piece, and the left-hand piece isn't defined at 8. Okay? Now, to do the other piece, same process. 7/4 x plus 1 divided by parentheses, x is greater than or equal to 4, like so.
There's a hole.
Now, there looks like there's a hole. We're going to talk about that in a minute. The calculator can deceive you. I'll show you. Okay, the second equation is on the projector as well as the TV screen. You can see it either place. That's what the equation needs to look like. But when you graph it, it kind of doesn't look like they connect, does it? Now, sometimes you're going to be asked to graph something and say, is it continuous? And it's going to be like pieces this far apart. And you're going to go, definitely not. But in some situations like that, it's kind of like, well, is the calculator kind of messing up a little? Or what's going on here? It has to do with the pixel size. If the pixel sizes don't match up, then it looks to be a hole, but it's really not. Here's how you can tell for sure. Okay? Here's what I want you to do. Go back to y equals and change both of these to say equal to. In reality, they're not. But I want to change this one to second math. I want it to be less than or equal to, which is number 6. And the reason why is because now it will show me where that first line actually stops. So go to the table. Notice that one column says error, then the other column says error. At the point where they change, if those two values are the same, that is actually showing the limits. And the two limits are the same, therefore it does connect. Okay?
Do you mean equal or like
Equal. No, you're supposed to put less than or equal to. Now I understand what your question was. Okay? Yes. The graph's not going to look any different, but the table will tell you for sure. Do the pieces really connect or not? If you make them both equal there, then you can see if they connect. Okay? Graphs can lie to you. They really can.